Hi everyone, I am Wayne Zhenyun Zhuang. I am going to present my study with Professor Yuan and Professor Pan. This study proposes a two-phase free medium regression approach, or called 2P3M. This is the agenda of the study. Unlike what is inside the conference paper, this presentation covers more because the research is about to be completed. To introduce it, we will take the way of illustration by example. So the example we have used is also important. In Zhuang and Zhong's study that dissected people's willingness to visit the mall when they are driving and facing the so-called dual pricing policy, there were a price P for the parking lot fee and another price S for the minimum spending in the mall to trade for an hour free parking. The key parameters related to their willingness to visit were estimated and investigated using a regression model. These included the perceived upper bounds of P and S, the perceived lower bounds of P and S, and the perceived importance of P against S, which was Z. Even all the parameters in the regression model was significant after estimation by observation of their p-values. The data model fitness measure, R-squared, fell within the gray area that was defined between 0.17 and 0.2. Therefore, that previous work had used two other regression models that were claimed to be more outlier-free. These include the least absolute deviation model, or LAD, and the quantile regression model, or QR. Eventually, these two models showed that even the R-squared value of the original OLS model was not fully affirmed. The data model fitness should be okay. Taking other models to verify a model is called the more models approach. This study is not to examine them, but to propose a new model for the more models approach. This means the model provides another method to examine the OLS model. The model is called 2P3M. As we will see later, the model can greatly improve the goodness of fit of regression modeling, and the improvement can be observed directly. This model should be more acceptable just because it also measures the fitness using R-squared. The LAD or QR models used other measures to show the fitness between data and model. They did not provide a way to check the improvement directly, but the original model is usually OLS model, and the measure for data model fitness is R-squared. Then the literature study follows, mainly for two parts. One, the ground to justify why the result is not so positive. Second, the foundation of the 2P3M model. This slide is the first part to review why the range to justify the gray area is reasonable. The basis of the 2P3M method is the free median or free M method, which inherits the concept of median regression, or MR. The free M method, or the median line model, in some studies is lesser known but effective alternative to the traditional OLS regression. This method suggests to divide the original data points into three groups with an almost equal size and create the connect the dots scheme based on the summary points of the low and high data partitions. A traditional 3M regression model deals with only one dependent variable. The 2p3m model deals with 2 by performing two phases of 3m, but as we will see later, the two phases are not identical, and we revised the method to calibrate the results properly. Now that 2p3m also differs from the repeated median line estimator regression in the literature. Another thing we have changed is the way in which 3m is performed. We find a regression line based on the 3 summary points of the high, middle, and low groups instead of just connecting the two dots of the high and low partitions. This concept is generalized to 3D when we have two dependent variables, so we find a regression plan based on the 9 summary points of the 9 cubes. These 9 cubes are partitioned according to the sorted data of the two variables. Anyhow, we propose a novel method for regression modeling, and since the 2p3m model provides the same data model fitness measure, just like the traditional OLS model, it can be used for triple checking in addition to the double checks using another two methods. Then here comes the methods and results. In this part, firstly, we introduced the adoption of the real case, and second, we illustrate by example using the OLS model and the data in the real case. Lastly, we give a summary to the proposed 2p3m method. This was the main OLS model in the previous study. The empirical data set contains 720 tuple of PSW, and in the model, P and S are independent variables. That is, X and Y axis as defined by 2p3m here. And W is the dependent variable. As discussed previously, even the p-values of the regression model itself and all of the estimated parameters are very okay. The data model fitness was in the gray area of the consumer behavior studies. The reason for this should be simple. Traditional OLS models are not free from outliers. Let's start from the 3D figure of the data points. There looks like a virtual plane in the figure that represents the data points, but there are also too many outliers in the data, so the data model fitness becomes poor. Then we do 2p3m. This figure illustrates the first process, where the entire sample is partitioned into 3 groups by variable p. Because the criteria for partitioning like this is that the number of data points in each partition should be equal or almost equal, while we observe the partitions on the x-axis. The 3 partitions are not equally spaced. Then, in the 3 main partitions, we find their median values along the x-axis. Their positions are the dotted rectangles. This is the second step. In the third step, we further partition each main group into 3. For example, in the leftmost first group, with a median of p equal to 10, the rule is to partition the 240 data points into 3 equal subpartitions of 80 data points on the x-axis. Once again, the subpartitions of each main partition stand unevenly on axis S. In step 4, we find the median of S with respect to each subpartition of 80 data points. For example, for the first subpartition of the first main partition, the median of S is $250. Not right at the middle of this partition. Here we have a summary for the former 4 steps of 2P3M. Step 5 is to recalculate the median value of P in each subpartition of the 9 cubes. Now we have 9 different calibrated median values of P. Then we can determine the W value on the y-axis, which correspond to each pair of the calibrated median of P and the median of S for each of the 9 subpartitions. This is step 6, like the numbers in this table. Based on the data in the table, another regression model can be established, also based on OLS. This is step 7. We will compare these results and discuss later. For time reasons, here we just summarize the mathematical parts of the algorithm and skip the relevant discussions about them. This is for steps 1 and 3, and this part is for steps 2 and 4. Finally, there is a step 8 to check the results and the effectiveness of the 2P3M model. This is a summary given to all of the steps included by 2P3M. We will show step 8 right now. We adopt a 4-dimensional framework to benchmark the effectiveness of the new 2P3M regression model. The 4 dimensions are efficacy, efficiency, applicability, and information productiveness. Then finally, we will make discussions and the conclusion. At first, the R-squared value is almost 3 times that of the traditional OLS, so the efficacy of the 2P3M model is evident. At the same time, sacrificing the significance of the model in terms of the p-value, not to a large extent, is the price to trade off for the great improvement in data model fitness. The previous study proposed to use the more models approach to re-establish other regression models than OLS and found supports for data model fitness using LAD regression and QR regression. 2P3M offers another way, and its applicability is shown in this study. It also avoids the effect of data outliers on the model's fitness. The most important thing is that 2P3M offers the same measure as the traditional OLS to check the improvements in data model fitness directly. That is the R-squared. Besides, this process also shows that using 2P3M can produce more information, and this means its information productiveness. And for the efficiency of 2P3M, we make an analysis for every step in terms of algorithms. The results shows that the complexity of 2P3M should be order n and order n of n at most, compared to LAD that requires uncertain time. The time of running 2P3M is more controllable, so its efficiency is acceptable. As 2P3M is shown okay in the 4 dimensions, theoretically, this model should be totally effective. Finally, the proposed 2P3M approach also contributes a new method to regression modeling. Besides, it provides a new way when one is taking the more models approach to verify the fitness of the OLS model and make sure the results. This is very important when the data model fitness falls in the gray area. On behalf of Professor Yuan and Professor Pan from Taiwan, thank you for your listening. That's the presentation today. I'm Wayne McGuire from NKUST.